right, go ahead and do the factoring and the math knowledge question. Once everyone is finished, you can unpause the video and then I'll show you the correct answers. So for this factoring, you're going to have to do a remove, replace, reduce. So we're going to remove the 5 by multiplying it by that 7, and then we're going to replace it. And the numbers that you would use to factor are -7 and a +5. This first factor will not reduce, but the second one will both divide by 5. So you'll have 5x minus 7 and then x plus 1. And that's your answer there. For the math knowledge question, it asks for the number of yards gained per running play in 1998. So that's dealing with this one right here. The number of yards gained is 1,417 per play. Well, we have 394 plays. And so if you divide those, you get about 3.6, which is C. Okay, so we are looking at lesson 71 today, dealing with the ellipse. And we are also going to go ahead and jump to lesson 89 after this, because it focuses on the ellipse as well. So we're going to look at 2 lessons, lesson 71 and also lesson 89. Hopefully you'll understand the ellipse after this lesson though. So an ellipse can be thought of as a flattened circle. The word that you probably learned in elementary school was an oval. But the mathematical term for an oval is actually an ellipse. So if you're talking about an oval, it's the same thing as an ellipse. Okay? It's a flattened circle. The ellipse is always going to be formed about 2 points. So you're going to have 2 points, and that's going to be the basis around which you form your ellipse. Each of the points is called a focus, and collectively they are called the foci. So foci is the plural of focus. But the 2 points that you use to make your ellipse are called the foci. The ellipse is the locus of all points, such that the sum of the distances from a point on the ellipse to the 2 foci is a constant. And I'm going to show you a picture in just a second. But it's going to be the locus of points, so all of the points, such that the sum of the distances from any point on your ellipse to your 2 foci is a constant. Think about a circle. It's the locus of the points that are all the same distance from that center, because they all are your radius of an R away from the center. Okay, so now the ellipse is going to be the distance from the 2 foci. When you add those together, it's always going to be the same for your ellipse. So looking here, the F1 and F2 are your foci, and if you take D1 and D2, as you move around your circle, those are always going to add up to the same number. So even if I put my D1 here and my D2 here, that distance, when you add those together, is the same as what they have drawn in. Same thing if I took it and connected it there. These 2 distances would always add up to the same number. So that's how you make an ellipse. If you look at another one, the foci are slightly closer together. Then we can look at another one here. It'll work for every ellipse. And then one more, whoops, right here. What happens as your foci get closer together? You see what it becomes? That last picture looks a little more circular compared to the other 2 or other 3. And then once your foci actually become so that they meet on top of each other, you are going to have a circle. Because if you have one foci here and the other one right on top of it, that distance and that distance, they're the same, and it's always going to be the same as you go around your circle. So once your 2 foci actually go on top of each other, you have a circle. So the further apart your foci are from each other, the more flattened your circle will be, and it'll be an ellipse. So an ellipse has 2 axes. That's the plural of axis. It has 2 axes. The axis that passes through the foci is always going to be longer, and it's called the major axis. So the one that the foci are on is called the major axis. Your shorter axis is called your minor axis. So you have a major and a minor axis. I'm going to go back to these pictures. Our major axis would be here, 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 and here. And then your minor axis is going to go through about there, there, maybe there, and there. You've got a major axis that the foci are on, and then the minor axis. Whenever you graph it on a coordinate plane, your major axis can be horizontal, vertical, or it can be inclined. So you can have a horizontal, vertical, or an inclined axis. So these are pictures. If it is a horizontal major axis, then the major axis is going to be a horizontal line. And if it's a vertical major axis, your major axis is a vertical line. And then we also could tilt it either to the left or to the right. Now, we are going to focus on the major axis being horizontal and vertical. We're not going to worry about graphing them if they are tilted. So we're just going to focus on if they're horizontal or vertical this year. This is standard form for an ellipse. X squared over a squared plus y squared over b squared equals 1. And I do want you to draw that picture, put detail into it so that you can see where the A and the B are. Okay, the A is half of the length of your major axis. The reason it's half, it comes from the center and it goes to one of your vertices. Okay, so that length over there is A, and this length here is also A. And then B goes from the center up, and then also from the center and down. That's also B. So that's the standard form if it is a horizontal. If it is a vertical, then it's going to be x squared over b squared, and then plus y squared over a squared. Your a squared is always the bigger number. So if it is horizontal, the larger number is going to go under the x. And if it is vertical, the larger number is going to go under the y value. Okay, so after you finish drawing those, we'll go on to the next example. So the letter A is always associated with the major axis, and it's half of the length of your major axis. So it's always associated with your major axis and half of the length of the major axis. The B is always associated with your minor axis, and it's also half of the length of the minor axis. So your A is your major, your B is your minor axis. And we also have this formula. It is not the same as Pythagorean theorem. It is a squared equals b squared plus c squared. It is Pythagorean theorem, but it's not a squared plus b squared equals c squared. Your a squared is now your hypotenuse whenever you're looking at your ellipse. Just because of the way they set up the variables, that's how it ended up. Your c is the distance from the center to your foci, and that's going to be the same distance over here. And then this is your B, and then your A is the same as the length that would have been from here to here. That is the same as that length there. So sometimes they'll give you your A and your B and ask you to find your C, or they'll give you your B and your C and ask you to find your A, and you'll have to use that formula a squared equals b squared plus c squared. I would recommend drawing that figure there so that you can kind of remember where your A, B, and C go on your ellipse. So we want to graph this. So everybody needs to get some graph paper. The way that you're going to graph this, we are going to look for our A and our B. Well, our A is always going to be the bigger one. So that's the 25. That is A squared. So our A would be 5. And then our B goes with the 9, that's B squared, so our B would be 3. This is centered at the origin, so we are going to go horizontally 5 in either direction. So we're going to go to the left 5 and to the right 5. So put a dot, 5 out on your left and right side, and then we're going to go up and down 3. So you can go up to 3 You're going to go down to -3. And then you are just going to connect your dots, and you're going to make an ellipse. So it'll look something like that. Obviously, you cannot use a compass to make these anymore because they're no longer a circle. So you're going to have to practice a little bit. It should not look like this. Remember, I told you need to make sure they are curved. Don't make it where you have straight sides. Okay, so that would be how you graph an ellipse. You find your A and your B, and then you plot your points and you connect them. Now we want to write the equation in standard form and then graph it. So the way that you get it in the standard form, it has to equal a 1. So this 15 needs to become a 1. So we're going to divide each term by 15. So then we're going to have x squared over 3 plus y squared over 7.5 equals 1. Once you have that, it's in standard form, and we can now graph it. So the way that we're going to graph it is to find our A and our B. Well, this is the larger number. 7.5 is much larger than 3, so that's going to be our A value. So our A is actually going to be the square root of that, which is about 2.7. And then the 3 is going to be our B. And so the square root of 3 is going to be 1.73, etc. So those are your A and your B. So now that we have those, our A was under the Y, so that means we're going to go up and down 2.7 on our Y-axis. So there's 2.7, and there's -2.7. And then our B was under the X, so we're going to do it on the X-axis. So there's 1.7 and -1.7. And now you just connect your 4 dots. Okay? So there would be your ellipse. So that's how those work. Okay, now let's look at a couple of examples from lesson 89. We've got the standard form of the ellipse with vertices at ±5, 0, and the foci at ±4, 0. So we want to write the standard form, but they don't give us the A and the B. They give us our vertices and our foci. So what that means, we want to draw it. Since it's at ±5, 0, that means that it is a horizontal ellipse like this. And this number here is 5, and this one is -5. And then we have a 4 and a -4. And so we want to draw out our triangle. We know this base is 4, the height is B, and the hypotenuse is the same as our A, which is 5. And so you can find your B using Pythagorean theorem. Your B is going to equal 3. And this was your A, and this was your C. So when we put it in standard form, we're going to have x squared over something plus y squared over something equals 1. Now it is horizontal, so that means that our A is going to go under the x. So A squared is going to be 25, and then our B is 3, so B squared is 9. And so this is the equation in standard form. Let's look at another example. We want to write the standard form with the vertices at 0 ± 6 and the foci at 0 ± 5. So in order to do that, we're going to start off by drawing it with a picture. Since it's at ±6 for the y value, that means that it is a vertical ellipse. So this number here is 6, and then we've got a foci at 5. So I'm going to draw in a triangle here. We know that this value is 5, The hypotenuse is 6 because that's our vertex right here. And then we've got to find the b value. So b squared and c squared equals the 6 squared. So b squared plus 25 would equal 36. And so b squared would equal 11. So our b would equal the square root of 11. So to put it in standard form, we're going to have x squared over something plus y squared over something equals 1. This one is a vertical, so our larger number needs to go under our y. It was a 6, and it is on the y-axis, so that may help you also know where it goes under. But y squared would be 36. Our b squared would be 36, and then our a squared, that is our a squared, I'm sorry. And then our b squared is going to be the square root of 11 squared, which is just 11. So again, our a was 6, so we squared it to get 36. Our b square root of 11 squared is 11. And so this would be your standard form. Okay, let's look at one more. We have a horizontal ellipse, has a major axis of 10 and a minor axis of 4. And the center is at the origin. We want to find the coordinates of the foci and write the equation and also graph it. So if our major axis is 10, that means that our A has to equal half of that, or 5. And if our minor axis is 4, that means that our B has to be half of that, which is 2. And so you can go ahead and write your equation. Our A is 5, so A squared is 25, and our B is 2, so B squared would be 4. And that would be your standard equation. It also asks for the coordinates of the foci, so that means we need to find our C. So A squared is going to be 25, B squared is 4, and then we're looking for C squared. So 21 equals C squared. So C is the square root of 21. So the coordinates of the foci, well, they're going to be on the x-axis because that's your major axis. So it's going to be at square root of 21, 0, and at negative square root of 21, 0. So those are your two foci. And now we need to graph it. We're going to go left and right 5. And we're going to go up and down 2. And then you just connect your dots. And you have your ellipse. And so that's how you would graph ellipses. You definitely do want to study those. You've got to learn the format of them so that you can do well with these. Once you have them, once you understand them, they're usually not too bad to graph though. Okay, so on your homework, you have none to omit, so make sure that you do those tonight so that we can go over any questions you have tomorrow.